Hello and welcome to the session. In this session, we are going to discuss the following question, and the question says that solve the following inequality: x cube plus x square minus 4x minus 4 is greater than equal to 0. Graph the solution on the number line. We have to solve the inequality x cube plus x square minus 4x minus 4 greater than equal to 0. We will follow the below steps to solve the inequality. Our first step is to set one side of the inequality equal to 0. Here we already have one side of the inequality equal to 0. So we move to step 2. In step 2, we have to factorize the given inequality. So here the given inequality is x cube plus x square minus 4x minus 4 greater than equal to 0. We can use any methods to factorize this inequality, like synthetic division, or by grouping. Here we will factorize the inequality by grouping. We have x cube plus x square minus 4x minus 4 greater than equal to 0. This implies x square into x plus 1 minus 4 into x plus 1 is greater than equal to 0. Here we have grouped the first two terms and the last two terms. And now x square into x plus 1 minus 4 into x plus 1 greater than equal to 0 implies x plus 1 into x square minus 4 is greater than equal to 0. As we know, a square minus b square is equal to a plus b into a minus b. Therefore, x square minus 4 will be equal to x plus 2 into x minus 2. So, x plus 1 into x square minus 4 greater than equal to 0 will now become x plus 1 into x minus 2 into x plus 2 greater than equal to 0. So now the inequality has been factorized, and now our next step is to find the critical points. For this, we equate each linear factor equal to 0. Here we have three linear factors, that are x plus 1, x minus 2 and x plus 2. Equating each of these linear factors equal to 0 and then solving for x, we get x is equal to minus 1, x is equal to 2 and x is equal to minus 2. So we have three critical points. Minus 2, minus 1 and 2. Our next step is to make a number line and plot the critical points on the number line. Let us now make the number line. This is minus 2, this is minus 1 and this is 2. Since minus 2, minus 1 and 2 satisfy the quadratic inequality, So, because of the greater than equal to sign, we will draw closed circles on these points, which indicates that these are included in the solution set of the inequality. So now our next step will be to determine the region based on these critical points. To determine the region, we draw vertical lines at these points. Now we see that the number line is divided into 4 regions. Region 1 has values less than -2, that is open interval -infinity -2. Region 2 has values lying between -2 and -1, that is open interval -2 -1. Region 3 has values lying between -1 and 2, that is open interval -1 2. And region 4 has values greater than 2, that is open interval 2 infinity. Next step is to check the sign of the inequality written in factored form in step 2 to determine which region belongs to the solution set. In step 2, we obtained x plus 1 into x minus 2 into x plus 2 greater than equal to 0. Now we check the sign of LHS of the inequality for each region by choosing any point in the region. Region 1 is open interval -infinity -2. Let us choose x is equal to -3, which lies in this interval. Put x is equal to -3 in the product x plus 1 into x minus 2 into x plus 2 and check its sign. Sign of x plus 1 is negative when we put x is equal to -3 in the factor x plus 1. Sign of x minus 2 is also negative when we put x equal to -3 in the factor x minus 2. And sign of x plus 2 is negative when we put x equal to -3 in the factor x plus 2. This implies the sign of the product will be minus into minus into minus, which is equal to minus. So we write a negative sign on the number line in this region. The next region is open interval -2 -1. Let us choose x equal to -3 by 2 in this region. So put x equal to -3 by 2 in x plus 1 into x minus 2 into x plus 2 and check its sign. Sign of x plus 1 is negative when we put x equal to -3 by 2 in the factor x plus 1. Sign of x minus 2 is negative when we put x equal to -3 by 2 in the factor x minus 2. And the sign of x plus 2 is positive when we put x equal to -3 by 2 in the factor x plus 2. So the sign of the product x plus 1 into x minus 2 into x plus 2 is equal to minus into plus, which is equal to plus. So we write a positive sign on the number line in this region. The third region is open interval -1 2. Let us choose x equal to 0 in this region. Now we put x equal to 0 in the product x plus 1 into x minus 2 into x plus 2 and check its sign. Sine of x plus 1 is positive when we put x equal to 0 in the factor x plus 1. Sine of x minus 2 is negative when we put x equal to 0 in the factor x minus 2. And sine of x plus 2 is positive when we put x equal to 0 in the factor x plus 2. So the sign of the product x plus 1 into x minus 2 into x plus 2 is plus into minus into plus, which is equal to minus. So we put a negative sign on the number line for this region. Now region 4 is open interval to infinity. We choose x equal to 3, which lies in this region. Put x equal to 3 in the product x plus 1 into x minus 2 into x plus 2 and check its sign. Sign of x plus 1 is positive when we put x equal to 3 in x plus 1. Sign of x minus 2 is positive when we put x equal to 3 in x minus 2. And sign of x plus 2 is also positive when we put x equal to 3 in x plus 2. So sign of the product x plus 1 into x minus 2 into x plus 2 is plus into plus into plus, which is equal to plus. So we put a positive sign on the number line for this region. So we have the following sign chart. So now our last step is to write the solution set in the interval notation and graph the solution on the number line. We have the inequality x cube plus x square minus 4x minus 4 greater than equal to 0. Due to the greater than equal to symbol, we will choose those regions which gives values greater than equal to 0. That is, positive values greater than or equal to 0. See, in the sign chart, we have two regions showing positive sign, which means these regions will satisfy the given inequality and will form the solution set. These regions are region 2 and region 4. Also, critical points are included in this region because we have inequality greater than equal to 0. So the solution set in interval notation is given by closed interval minus 2 1 union interval to infinity closed at 2 and open at infinity. Now we graph the solution on the number line. For this, we darken the number line from minus 2 to minus 1 with closed circles at minus 2 and minus 1, and also the line from closed circle at 2 to infinity. This is the required graph of the solution set. With this, we complete our session. Hope you enjoyed this session.